I have some examples this is examples of calculus 2. The first example is trig substitution, where the substitution is x equals sine theta, dx is cosine theta, d theta, and this is used to solve this integration from 0 to half x cubed square root of 1 minus x squared dx. When you do the trig substitution as x sine theta and dx cosine theta, then you will end up solving this integration. Then I have also a trig substitution of integration dt over t squared square root of t squared minus 9. This is obviously the trig substitution is t is 3 sec theta, dt is 3 sec theta tan theta d theta. Then you do the trig substitution, you will end up with square root of t squared minus 9 over 9t plus c. So this is basically just an overview of the solution. And here I have another example. This is volume by cylindrical shell method, which is a disk method, and this is when you rotate the area bounded by y equals x squared and y equals 8 minus x squared about the x equals 2. You sketch the region, of course, then the radius is r equals 2 minus x. The third circumference is 2 pi r, which is 2 pi times 2 minus x. The height is f of x, which is the top curve, minus the bottom curve. So when you do that, the height is 8 minus 2x squared. Then the volume is just from a to b 2 pi r f of x dx. That's the integral of that. So that is from minus 2 to 2 pi. R is 2 minus x. And the f of x is 8 minus 2x squared dx. When you integrate this, we'll end up with 256 pi over 3. Then I have another example, calculus 2, and this is representing a function as a power series. So this is the derivative of 1 over 1 plus x. It represents this as a power series. So this is the same as representing d by dx, this power series 1 minus x plus x squared minus x cubed plus x to the 4. This is the standard. So when you take the derivative of this is minus 1 over x plus 1 squared, and you take the derivative of the power series, which is minus 1 plus 2x minus 3x squared, and so on. So this can be written in a sigma notation, n equals, in a sum notation, n equals 1 to infinity minus 1 to the n times x to the n minus 1. Then I have here another power representation of ln 4 minus x. This is the same as the integration of minus 1 over 4 minus x dx. So that integration is the same as ln 4 minus x. And this can be written as 1 over 1 minus x over 4. Then this can be written in a power form. The power series of this is 1 plus x over 4 plus x over 4 squared plus x over 4 cubed plus x over 4 to the 4 plus x to the 4 over 5, and so on dx. When you integrate this, you will end up minus 1 over 4. The integration of 1 is x, then the integration of this is 1 over 4 x squared over 2, 1 over 16 x to the third over 3, plus 1 over 64 x to the 4 over 4, plus 1 over 256 x to the 5 over 5. Then this can be written in a sum notation, minus 1 over 4. So the x's are x to the n plus 1, they are increasing by 1, and the the force are increasing by 2, that's they are 4 to the n, then you have 2, 3, 4, 5, which is n plus 1. Okay. So this is basically the power series of ln4 minus x. Then I have here area in a polar coordinate. If you have r equals 6 cosine theta, to write this, to find the area of this in a polar coordinate, this polar coordinate, it is a equals 9 pi. So and this is basically a equals from 0 to pi over 2 half r squared d theta, which is from 0 to pi over 2 half r is 6 cosine theta. Then this cosine squared theta can be written as 1 plus 2 cosine 2 theta. Then when you integrate this, you will end up with 9 pi. So you take the integration from 0 to pi over 2, which is only the top half circle. Then this times 2 is, you just double it, then you have the whole circle. Okay. Then I have another trig substitution. So this is the integration of dx over x squared square root of x squared minus 4. So this is obviously x equals 2 sec theta is the trig substitution. Then dx is 2 sec theta tan theta d theta. Then when you substitute, you will end up with 1 over 4 cosine theta d theta integration. When you integrate that is 1 over 4 sine theta plus c. Then this is, when you draw this triangle, this is theta. So sine is opposite over hypotenuse, which is square root of x squared minus 4 over x. Okay. And I have here some beautiful three-dimensional pictures of this is to show the beauty of mathematics. Beside every technology we enjoy, here are some beautiful math images. So this is actually, this is a polar, this is an trigonometry graphs. Those are in polar coordinates graphs. Then I have here area of surface of revolution examples. So for example, here you have a cylinder. So when you cut this, so the surface area of the cylinder is simply just the area of this rectangle. Okay. Then I have here area between two curves. So to find the area between the two curves in calculus, you basically integrate the top minus the bottom from A to B. So you will get this area, the top minus the bottom integration, and you evaluate it from 0 to 1, for example here. And this is the top curve minus the bottom curve. You integrate from 0 to 1. Then this is it is the right curve minus the left curve. You integrate this from -2 to 4, and here also you have the integration of the right curve minus the left curve, integrated from -2 to 4 again. Okay. Then I have here examples of some pictures of volume by slice method. For example, this is a sphere. When you cut this sphere into discs vertically, then you add all these discs, then you get the volume of the sphere. And so on, also the other figures the same. Then I have here volume by cylindrical shell. You revolve this figure and you end up with you will integrate you will cut basically a cylindrical shell out of the figure, and those are, you add those, integrate those, and you will end up with you will end up solving the integration basically.
When I can't be choking on the chain, does you blow it like a fan? When you're trying to optimize, you gotta make the sound charge. Then you maximize it, man, I'm not in the right part. No more gets intensive, find the nice with a hairstyle. Never see the winner because I ain't been a bypass. Survive and find the slope instantaneous, spread and change. Teacher Joseph Sabota, you best not be forgetting names. The toughest parking system, all the sneakers is a series. Struggling with ratio, I'm rooted till I'm weary. Memorizing Taylor and McLaurin so severely. That's a lot of information, I don't even know it clearly. I be curving when I integrate. Direct comparison, imitate. If limit approach, I hope results are n equals 0, the cut with the struggle to play.
Let me hit it real quick. Yeah, I'm round my boys, you know we scheming. You overestimate your skills, call you left reaming. Catch the integral, I swear, got the area under the curve. Doing derivatives, turn my TI 80 bird. First, calculus, don't mix plus. Lose the right when you see the plus. Think you be so tight with your calculation, go rolling. I'm a pro, give me a call. Trig identities, know them all. If you think you are better than me, I'ma send you to the L hospital. DYDX, you know derivatives. Y prime cosine equals sine negative. Even if you got these memorized, it ain't really no benefit. When it comes to finding maximum, I'm absolutely your relative. Let it breathe. Hey, slow, get it done. Rise